Hi there, everyone. Welcome. Let's get going. So, anybody want to discuss the various approaches or notebooks that Raquel shared or other things they would like to talk about?
Happy New Year. I haven't been haven't been able to make it for the last couple of weeks. Yeah, so I have no idea where you're up
Happy
to
New Year, Steve.
or what you're doing. So
Yeah, we are kind of just last week we kind of decided that we'd probably jump on to the new um, competition that you had posted a notebook about and human, what's it, brain related classification with EEGs and spectrograms and all that kind of stuff. Before that, last week we did discuss the competition that very quickly about approaches to detecting LLM written essays versus human written essays, and like I covered the major approaches using for that, and kind of one of the major things that people were trying, which was to use test data for generating some of the vocabulary, which is not normally the case. So things like that, we discussed a couple of competitions last week, and then decided also last week that we would probably jump into the human brain analysis competition. So we're kind of just beginning. This is probably the first week that we are talking about what the data is and all that. So that's
yeah, so I entered that competition when it started, whatever it was, like 2 weeks ago or something. So yeah, so I've been at it from the start. Yeah, it seems quite a good competition. Like there seems to be like a lot of ways to tackle it. So I like your guy Chris Diott's taking part. So he's like put like a lot of good notebooks up, and in the discussion he sort of describes all the data and gives a very good introduction to things.
Yeah, I commented on your kind of discussion post, or was it like a?
It was a public notebook. Yeah, I just sort of made a notebook myself just to try and understand the data, because I didn't really understand how it was like laid out to start with. But yeah,
Yeah,
like
it's
since I made that,
pretty
there's other
complex
ones.
to retain in the head. I still periodically have to go back and think about what does this mean and how is it kind of correlated, and things like that, right? Because like from the EEG, you go to the spectrogram, and then there are multiples of spectrograms, and there are multiples of EEGs, and spectrogram is 2 seconds per row, and all these kinds of things that you have to carry around in your head, because how you deal with the data depends on that. So it's kind of, I think that's probably typical, but it's just quite a bit to make sure, quite a bit of context that you need to have for this competition, I think.
Yeah, like I think it looks like sort of complicated when you first look at it, but once you get into it, it's actually not too bad. I think part of the complication is the fact that, yeah, like to cut down on the number of files that they've put out, they have like EEGs which are sort of shared across a single Parquet file. So yeah, like within their training data, there'll be rows within that, and like with this sort of the guess or the whatever, the experts are trying to predict what type of brain condition it is, and so like each row is them making their votes or whatever to say what type of brain condition it is. But yeah, like a single row will be only part of a Parquet file, and so yeah, like they've just sort of split for like a single patient or whatever. There can be like one Parquet file which is covered by like maybe 10 or 20 rows or something. So, and like then the
Yeah, and
EEG.
then there is a correspondence between the EEG and then the spectrogram file so much.
Yeah, like then the EEGs,
Trigger.
yeah, like each EEG Parquet file has 40 columns or something like that, which correspond to like the different locations on the head that the readings have been taken from. But like then, as you say, yeah, Kaggle themselves have taken those EEGs and turned them into a spectrogram, which is associated with the EEG. So like all of the solutions I've seen so far have just worked on the spectrogram. I haven't seen any working on or I haven't used any that work on the EEGs. It's just looking at
Yeah.
spectrograms.
Yeah. And in fact, one of the things I was thinking of actually went back and forth. And I thought originally that it was kind of an image classification thing. And then when we quickly scanned it, I kind of was confused because I think Chris' approach initially was just to use the tabular data. So he used Catpost, but you could kind of go either way, which is another interesting twist that you could kind of analyze it as a tabular data thing, which is what he did initially with Catboost. But then, you can also, he didn't get that great a result and he kind of switched his next approach to using efficient net. And obviously there's this Tawara guy who used
Yeah, he uses ResNet, the other guy.
ResNet 34D. Yeah, yeah. And
Yeah, so like
yeah,
the public solutions at the minute that get the best score are basically just doing like image classification on the spectrograms, as you say, like using either EfficientNet or ResNet.
Right. And in fact, one thing I was thinking of, given that approach, or just image processing kind of, or image classification, basically, is to go back and look at some of the things that were done in the bird recognition competition, because I recall in that the two things that that are stuck in my mind, and I wanted to ask the question whether anybody else remembered anything else in particular. But the two things that stuck in my mind were, one, in that competition, I think what you and a few others had done, if I recall correctly, is it depended very much on the slice of the spectrogram that you took. So that, the selection of the slice became important in that. And I didn't know whether it was because, where the bird noise is versus the background noise was important in that competition. So I was kind of, that was one thing that stuck in my head. So I was wondering again, in this case, is there any kind of narrowing down of or zooming in, if you will, within the spectrogram that would somehow help?
Which notebook is that?
No, I'm not talking about a particular.
Okay.
I'm not talking about a particular notebook in this competition, Mike. I'm talking about the strategies that I recall people using in the bird sound recognition competition, which was again a spectrogram classification kind of competition. Mm-hmm. So I was that we had participated in, I don't know, maybe a year plus back. It's not very recent, but that is the last one that I recall where, excuse me, where we had looked at spectrogram analysis to classify and capture different classes of birds from the type of sounds they make, and the sound that they make is hidden, quote unquote hidden, meaning it is in a particular portion of the spectrogram, but you don't know which portion. So my recollection was that narrowing down or zooming in on that portion where you expect the bird sound to be was kind of important from that. And the second thing that seemed to matter in that competition, at least I'm talking from memory, so I wanted to go back and check whether my memory is right, is the kind of, and few people have introduced the concept in this competition already of doing some kind of augmentation, to help classify better. And the augmentation that mattered for spectrograms was very particular. And that's something else I wanted to go back and look at that competition to see what were the specific types of augmentation that worked well for spectrogram classification. Is what I'm rambling about, does that kind of ring a bell, Steve, since you had participated in that competition, I recall, or does that?
Yeah, so I remember using spectrograms to like try and find what type of bird it was that was in the forest or whatever. But I think the reason we were like sort of slicing the spectrograms was like because the spectrogram, the bird noise might only occupy like the middle of it or something. And so rather than like looking at the whole thing, we were slicing it to like try and identify the area where the bird noise was being made. So like I'm not sure if that's applicable to this. Like obviously like this one here is just, yeah, like somebody's brain has been analyzed. So you don't have to go and find where it's being analyzed because the whole spectrogram represents the readings taken from the person's brain. It's not as if you have to go and search for the noise in it. But yeah, I know what you mean about sort of different types of augmentations on the images, but I can't remember what we used. I would need to look back.
Yeah, no, that part I don't recall either, but I was wanting, but just to argue with your point about the bird noise being, I agree with what you said, but what I was thinking is at the end of the day, even in this competition, or at least I wanted to explore this idea and see where and check its relevance. I haven't convinced myself that it's not relevant. Is, you know, even here you take the spectrogram over like a large window, right? Like a 60, 10-minute window.
Yep.
But then the EEG and stuff is for, if I recall correctly, 50-second window around some center point. Is that does that sound right? About a 50 seconds.
Yeah, so like the spectrogram, as you say, is like 10 minutes long, and then there might be, like say 20 rows, each corresponding to a 50-second EEG window, and like those windows are on that spectrogram.
And what I was wondering is the entire 60-second relevant to the classification of the condition, like seizure, blah, 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 or are there, narrower windows? Because if it is narrower window, then, one of the things I already saw is it seems like having a bigger, like, Chris Deott's first notebook was something like 128 by 256. And then he was like creating channels by overlapping the images, like putting one image, putting 4 images of 4 spectrograms of the same shape, like 128 by 256 back to back, and then flattening it, if you will, into one channel by reshaping it. Whereas the guy who currently has the best public does this 512 by 512 by single channel. So the point being that it seems like the larger resolution that you have, like 512 by 512 and single channel, seems to beat, the other guy by substantial margin. So I was just wondering, is there an opportunity to narrow down, because the 512 by 512 is again handled over the entire 600 minutes, 10 minutes, if I recall correctly. So that's what prompted the thought about, is any narrowing possible, or is it not needed? So I just haven't, it may not be appropriate as you point out, but I just wanted to kind of bring it up. That's something I was thinking of.
Yeah, like it is possible. And I've noticed that Chris Deott now, what he's doing is he's gone back to the EEGs, and there's a thing, waveform or something it's called.
WaveNet.
Where you
using, yeah.
Sorry, what?
WaveNet.
It could be that, yeah, something like that.
Yeah.
So he's taking like the EEGs and sticking it through that to make spectrograms, to make his own spectrograms. And like, because the EEGs are only 50 seconds long, he is getting sort of more targeted spectrograms. But yeah, like he's obviously got problems in that he's making them himself, so they may not match up with the Kaggle ones. But
interesting.
And the other thing that Yeah, the other thing he does in his spectrogram classification stuff, within the training data, it gives you like the offset for each row. It'll give you the offset time into the spectrogram where the 10-minute window starts. So like each spectrogram may correspond to some. And what he does at the minute is he takes all of those windows within a single spectrogram, and then he averages the votes for that. And when he puts it into his like training data, he has a start point and an end point, which is like the minimum and the maximum of those offsets. And then like he averages over that, but like when he's training, he can take like any point in any of that. But sometimes you may have like blanks or whatever. And the other thing that he does, there's actually 4 spectrograms per patient or whatever, at like 4 different quadrants on the head. So like your front one. And what he does, he sticks them into the efficient net as sort of 4 different channels. So like because you got 4 spectrograms, he puts them in as 4 separate images. Whereas like the leading public notebook, it combines the 4 spectrograms into a single image and puts that in as one image, as opposed to 4 channels.
That's where, that I mentioned, the 0.46 scoring notebook, which is 512 by 512, and then but single channel, whereas what Piot was doing was taking a 128 by 256 and then rearranging, but then he might have, once he figured out how, and there were some images I saw of him figuring out that the 400 readings are probably broken up into 100 for each of the 4 quadrants or something like that. I mean, chase that down to fully. That's kind of what you're referring to, right?
So Steve, could you explain this via your notebooks? If the EDA ones has that representation there.
What's that, sorry?
Could you please explain this via your notebooks? If your EDA notebooks have those spectrogram representations with respect to the 4 quadrants and the 4 parts.
Yeah, if I can share my screen, I might be able to make it. Can you see my screen, sorry?
Yeah, we can see it.
Yeah, I just need to find the right. Yeah, so this is the notebook I created. So like to start with, I was really like just looking. Yeah, so like this is the training data you get. So yeah, so there's like 6 different categories. In this case here, so you got like 3 experts, or like trying to say which condition the person has. So like all of them have voted in this case for like the person have a seizure. But actually, like when you're training your thing, you don't want to like get this to be 3. You want to get the probability for each category. So like in this case, it would be 1 because all of them have voted for that. In the EEGs, so yeah, so like for each row, you get like an EED and EEG, and then it can be like times offsets into the EEG. So you'll get like a single image. And yeah, so like here is a single like Parquet file. And as you can see, like each one of these columns represents a different location on the head. So like these are like the columns. So I presume that's the person's nose and that's their ears or whatever. So yeah, like it's just like readings taken here. So yeah, for a single EEG file, so like here, like the green line represents the start of like a window, and a red line is the end. So this is like the EEG. That's the first window from this green line to the first red line. Yeah. Yeah, so on the spectrogram thing, it's hard to say in this picture, but yeah, like there's 4 quadrants. So it's like here's one quadrant, then on the other side there's one, and then there's the ones in the middle, or the ones at the back as well. Yeah, so you get 4 spectrograms. So like this would be like, say, like the front left of your head and the front right of your head and the back left and the back right. So those are the 4 spectrograms you get, and like that's what all of the public notebooks have been using at the minute. So this here, this is like Chris Diot's one. So like, because of the fact he sort of reshapes them just to fit with how efficient net wants its input. So you can see here, like in some of them, there's like gaps because of the fact that, yeah, like the start of this is like a window that's used for one of the EEGs or whatever, but then there's a gap that's not actually used by any of the rows. And then there's like the rest of the data which is used. And so, yeah, so he would take the 4 spectrograms I showed you before and stick it in. Whereas, I'm not sure if I have a picture of it, but
those overlaps are avoidable, or in the sense that those overlaps with respect to how they are represented are in the sense the time windows I was referring to, are they kind of like uh, how do I put it?
Do you mean sort of the gaps in the spectrograms?
Yes, the gaps with respect to the windows.
Yeah, so within a row, it'll tell you what spectrogram it's using, and it'll tell you the time offset in, and each spectrogram window lasts for 10 minutes. So, yeah, you could chop out the gaps, but as I say, like in Chris Diot's code at the minute, he's just like averaging over like all the rows that use the same spectrogram. He averages over them. So like actually in his case, he probably would be, yeah, like looking at those areas that don't have any spectrogram data. Yeah, he's got like a discussion post. This is probably like the best explanation of getting started. And yeah, some of the
pretty good
res.
too. Your stuff. If you can, I can share the thing where he tries to generate, or at least he shows how he's generating the spectrogram from the EGG.
Yeah. Oh, yeah. So here, yeah, like in this one here. So those are the 4 spectrograms. And as I say, in his notebook, he makes 4 channels on his input, whereas like the highest scoring public notebook, it does this. It stacks the 4 on top and just makes a single image. So yeah, like it just puts it in like that. It also resizes it, like the one that's winning at the minute, it's resized it to 512 by 512, whereas yeah, Chris Diot in his model, he doesn't resize it. He gets it so as it matches with what EfficientNet wants, which is why you've got like these borders at the top and bottom, because yeah, he hasn't resized it. He's kept it the same as the EfficientNet standard input.
Guys, I have a question in this competition. What are the features for the model? So is he taking he creating parameters from these images? Like for example, the LL and LPLR, so all these spectrograms sides right and left. Is he averaging the values and adding it to the spectrogram data frame? Or how is the idea of creating features to fit the model?
Yeah, in fact, that's the thing, right? It's kind of interesting is when you convert the tabular data to a image, then with the image processing algorithms, you don't have to create the features. The features are embedded in the image, and therefore, with a CNN or with like a ResNet or EfficientNet or any one of these things, you don't have to, when I say you, I mean we do not have to worry about creating the features, which he was doing with CatBoost, right? With CatBoost, for example, to contrast, he was kind of like taking the min and the max of the tabular value, averaging out the time, and then creating the min and the max under, I forget, there were two other things. So totally you ended up with like 1,600 features, 400 times 2, and then that's 800, and then 600, and then that duplicated. Whereas with an image and with CNN, you don't have to create the features. They pick up the features that matter to them. By they, I mean the network picks up the features that matters to it with respect to the goal.
So there are like two approaches. One approach is to, let's say, average the values from the which file it is. So you have these spectrograms files, these Parquet files. For each spectrogram, you have Parquet file. So you can, let's say, average all the values for all the columns, for example, and then add it to the spectrogram file, or to the main file, to the train file, where you have all the data. No, but I have seen some people aggregate the train data. So you only have one row for each spectrogram, and then you can add there more features taken, for example, for each spectrogram. This could be one approach, right? And another approach would be to create images from each spectrogram and then use these images to feed a model. So am I right with that? So there are like two different approaches?
Yes.
Yeah, at least those two different approaches.
Okay. And okay, so which features, for example, you take features, which features might be interested now? Only minimum, maximum from the whole data set? Or because I have seen Chris has created like a MPI file, like a file with, I don't know how many features in the data frame. And to be honest, I could not find out how he did create these features.
At least he's created one NPY file, which is basically just, instead of reading each spectrogram in, he's read all those 11,000 spectrograms in and created one NPY file. So it just makes reading and processing faster. So it's, I think there is no feature creation on that one, at least the one I'm talking of. I'm not sure if it's the same file.
That's correct. He just combines all the spectrograms, each of which is in a Parquet file, into a Python dict, and stores them as a single entity, so that when you open, you have access to all of them. That reduces the open close problem with, that you have to do over 11,000 whatever, or 17,000 Parquet files into opening a single Kaggle data set that has all of them. There's no feature generation in that. It generates the features in the CatBoost notebook, and the features are the min and the mean. Those are the two sets. But remember that there are, if I recall correctly, in the spectrogram, there are 400 locations in which you can take the mean. And so there are 400, columns? Yeah, 400 columns that you have. And if you're taking 400 columns.
Okay, so that's the mean value of each column, what he's taking in this train Parquet file, right?
Yeah, he averages, he takes the mean over, not across the columns, across time. So it's across the rows, not across the columns. He said he tried across the columns, that didn't work. So he so he took it across the rows, the mean and the min for the time, and thereby eliminates time as a variable, because if you have kind of taken the average or the min, then basically you just have a single row, and you have, instead of 400, you now have 800, because you have 400 values, but you have the average of those 400 values as one set, and you have the minimum of those 400 columns as another set. So now you kind of concatenate them, if you will, as rows. So now you have 800, and then there is some other thing why there is 1600. I can't recall now off the top of my head. Maybe regular Steve can. But so he creates 1600 features and uses them in as features in helping the CatBoost algorithm produce a result.
Okay. Okay, so that's that's the one approach, take the features, and the other one is creating the images. Okay, cool. And so far, which one is working better for the models? Because I could not try it out so far. I mean, I did some analysis to understand the data set, and I would like to try in the next weeks some modeling. So which approach is working better right now? The images one or the features one?
The images one.
The images one. Okay. Yeah, I need to try it out because for me it was a bit complicated to understand this data set. I have no idea about brain issues, and took me a while to understand all the features and what does it represent.
Yeah, and
Yeah, it is a-
kind of share the whether you folks see.
Yeah, I can see it.
Yeah, so this is what Steve was talking about of how he converts. Steve had also shared this picture of all these points are where the readings are taken, and there are like 4 quadrants or 4 segments or quadrants, I guess. And then he you know, he being Chris talks about how he creates the spectrogram from EGG, and by combining each of these as like this 1, 2, 3, 5, and then another one, a set of 5. There's some overlap, obviously, and then the blue and the green quadrants to kind of create himself from an EEG creates the spectrogram. So this is the picture which he uses to communicate how he converts the EEGs into spectrograms. Now, the leading public notebook does, as Steve shared, he doesn't bother about using these 4, or actually he does, but that's where Steve had already shown how that guy collapsed the 4 of these, but he doesn't generate it. He just uses the already generated spectrogram, whereas Chris Viotti creates his own spectrogram from the EEG data, whereas the other guy uses the spectrogram that's already available, that's already given to us.
Yeah,
But this picture shows how he
does Chris also do some sort of optimizations with respect to creating the histograms there?
That I don't know. Steve can probably talk.
Okay. So there are a number of signals. So then he might do something with signals to boost its capacity.
He has a
And-
notebook. Sorry, go ahead.
Yeah, like in his just his baseline efficient net notebook, he doesn't do anything. He has some stuff in there about adding augmentation, but it's commented out. So at the minute, he doesn't do anything. He just sticks the raw spectrograms into the efficient net.
Okay.
Talking to you also, I think Mayank was specifically asking about whether he's trying to boost these EEG signals while converting into spectrograms, right?
Mm-hmm.
Okay, so he has a notebook where he actually walks through, that's the discussion post. There's a notebook where he talks about all this bipolar double banana montage. Let me share my screen. And he uses some, the Librosa, I think, for conversions. Chat. Yeah, so that notebook kind of does the transformations from the EEG to the spectrogram.
Okay.
So I actually want to kind of take a step back and kind of look at some of the EDA stuff. So shall I share my screen?
Yeah, I had some questions on even what he's doing in efficient because I couldn't quite grasp why he was taking
Yeah, you
certain
guys have
jobs.
gone way further ahead than I have. I'm still
Yeah,
stuck.
yeah, no, but I think I agree with you that it's good to kind of go through the EDA thing and kind of really grasp the nuances of the data set because I was still, I still had questions about this kind of stuff where he was saying, how do you probe and with overlapping and without? And I was like, how do you do that? So it's good that we are going back. So good thing to do.
It took me a while to get a hang of the data set with Steve's notebook and with like Chris Steward's notebook. But yeah, and actually, talking about the expanding stuff, I still don't know the answer, but aren't we just predicting like the middle 10 seconds? That's what the test set is supposed to have at the end of the day, right? So, too many tabs open, sorry.
Yes, which is I think at least when it comes to test prediction, correct?
Right.
Yes, which is the reason that I was saying, is there any kind of
Scope out there? Okay. I
hope
see.
for narrowing the relevant part, but then blowing it up to
Okay.
give better resolution?
I see.
That's what was prompting my thought along.
I see.
While I understand what Steve is saying of, in the other problem of bird prediction, he's right that, the sound of the bird was hidden among a bunch of noise. So, and then you'll have, ongoing noise, and then suddenly you'll have a bird sound. And so you needed to kind of like, you don't know a priori where in a window the bird sound resided, if you will.
Right.
So that was a hard problem to solve. In this case, that's not the case. We know that we are predicting in the middle 10 seconds, for example, when it comes to test. But at the same time, I don't know enough medical things to know how important the entire 600-second window is, or where in the 600-second window are the waveforms which help the experts predict that something is a seizure versus whatever, LPD, GPD, blah, 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 right? That might depend on the entire window, or it might depend on a narrower segment of the window. Even though you're predicting for the middle 10 seconds, the context might still matter. And that's the thing that I was just wondering about. Is there any opportunity to kind of narrow that window down?
Only this 10-second was what was provided. So I didn't realize that there could be potential context outside this window in the test set. So yeah, I still don't understand how the test set is completely built out then. Because I was assuming that only this much is going to be provided and you won't be seeing the rest of it at all. So
that's now that you mentioned, see, this is why I still can't claim for myself that I fully understand. Steve, I forget now, is the test set provides a EEG and a spectrogram, correct?
It does, yeah, but like, unlike the training data where there's like an EEG file that can be for several rows, each row, as far as I'm aware, each row of the test set has its own EEG. So it's not as if you've got like windows onto.
Right. So you should have just one ID, one spectrogram, one EEG ID, one spectrogram ID corresponding to just that one section of the image that you showed with those multiple green lines and red lines, right?
Yeah, I think so, yeah.
Multiple rows of that, yeah.
Right.
Yeah.
But it has one spectrogram, which means that it would have, and both are centered, right? They are centered on the same center. The EEG and the spectrogram are centered on the same center.
Yeah. But yeah, like the
spectrogram,
EEG
would be
for 10 minutes.
Center.
Yeah. So
go ahead.
The EEG is 50 seconds, and you want the middle 10 seconds, and the spectrogram you're given is the 10-minute thing. And again, it's the middle corresponds to the actual prediction.
Which
Cool.
Which kind of the deep learning methods or the CAT boost and the boost ones work better?
So the CNN approach, which is efficient at ResNet, I think ResNet 32D or something is the one which is currently leading.
Mhm.
Yeah, like at the minute, it seems much better than the cat boost.
Yeah, can be cat boost for sure. Yeah.
And keep in mind, as Steve or Rekil mentioned, one of the things which is still nobody has cracked this mystery yet, or not mystery, but this puzzle or whatever you want to label it, is how to combine everybody, as Steve said, is just using one data point or one type of data, which is the spectrogram. Nobody has yet figured out how to, I think Chris said he is working on it and stuff and has been trying variety of things, is how to combine, because obviously beyond, I mean, there is a correlation between spectrogram and EEG, but EEG data is separate from and gives you a bunch of data that guys correct me if I'm wrong, but they're not available in the spectrogram, and nobody has figured out how to combine or how to use EEG and spectrogram to create a model that could help.
Yeah, there is a startup from from Chris, which uses the EEGs. So he's using a WaveNet to predict.
Right, but that is using EEG to convert, as I understood, and I haven't looked at this. So
no, that's a different
but
one.
he just takes the EEG to convert it to spectrogram and then analyzes the spectrogram.
This one. So the conversion is a separate notebook. This one is using EEGs, where he's using basically, if you see, he's doing this, which is basically this point minus this point as one feature and FP2 minus O2 as another feature. So right now he's just using just those two, and he's kind of creating the whole thing with a WaveNet styled architecture, which is something to do with sequences, right? When sequences are there, WaveNet is something that you can use. So,
so this is based just on EEG, though. It again doesn't combine EEG and spectrogram.
No, I think he makes a mention of that you potentially could. Yeah. See, furthermore, we can build one model which inputs both spectrogram images and EEG waveforms, and then you could potentially combine those two up. So yeah, I mean, I can't believe like it's been 10 days and there's like so much stuff already out there to cover.
Actually, I was completely lost when I entered.
Yeah,
so much information that I don't know where to start checking.
Yeah. In fact, some of the challenge, I think, and this is what I personally enjoy about Kaggle in a sense, is it almost seems at some point it's your ability to kind of quickly sort through a torrent coming at you and figure out like what matters and what doesn't, and you're like, you're drowning and you just want to keep your head above like fire hose of water pouring onto you.
So sorry, let me just quickly run through. I had a couple of questions.
Only a couple, man. I had lots. I had jotted down, so good thing they're going.
At least I mean, I haven't reached as far as you guys, so I think mine is just a couple. So yeah, submissions and probing of leaderboard was something. I was seeing. I've never really done that, and it was interesting to see these approaches. So, I think the simplest approach that one could try was you have 6 potential targets and you weight them equally. So that's why you say 1/6 is the probability for each of them, and you make a submission and you kind of get back a leaderboard score of 1.09.
Now, sorry, question right there. He says then, so I understand the with equal probability. Then he says with overlapping LB 1.1. So how would you, or what does he mean by that, and how is that different? The equal probability, like you said, is just setting, just set the probability for all 6 targets to be 0.16667 or 1/6 and submit it, right?
Yep.
Now, what is this with overlapping mean?
Hang on 1 second before we jump the gun there. I'm going to come around this the other way. I'm going to start from the ones that I understood, and then he'll go to that one because that one I'm not 100%
fair enough.
So then so that was the first one. And then if I'm guessing everyone's at least kind of seen how the data set look like. So this PID is basically your patient ID. So another simple approach is you can kind of group by your patient ID and then kind of say for each of these patients, these are all my votes that are possible. So you kind of sum them up and then divide each of them to kind of give you what your means would be. So this is if you were to group
When you say means, sorry, just a question on that. So that would mean that per patient, you sum up the votes and then take the average of the votes per target category. Is that what you're talking about?
Let's look at it here. Yeah. See, this is exactly what the code should look like. So you group by your patient ID. Looking at your targets, you sum across these axes. So it kind of gives you the values for each of them. Then you do this.
Wait. Sorry, the first sum is across the rows. I mean, sorry. Yeah. The first sum with no axis is across the rows, correct?
Yeah. And let's actually do this.
Each of the time. No, stick with the code you showed. Stick with the code. Go back down.
Just to run it. So
where you had
yeah.
So all I'm saying is the very first sum. See, you group by patient ID, and then you do the targets dot sum. That part sums, as I understood it, across the rows, correct?
Yeah, that's what. Give me 1 second. Let me just run it so we don't have any. Where are my targets?
Right, I wanted to do this, so I'm glad that was on my.
There you go.
We'll take it step by step.
So this is what is going to be the sum. So this is basically for each patient ID because you have these multiple rows for each patient, right? So you're getting like the total votes of seizure, you're combining them. So you're combining across rows to get just one row.
Correct. Yeah, right? That's what I was saying. The first sum is across the rows per patient.
Yep.
And then the next sum does the
total votes, because you want to kind of calculate probabilities like what Steve was saying. You don't want the number 3 or 4 as the number of votes. You want a probability of the seizure vote and probability of the votes. So you need.
But even here, it's just giving you the total though, right? It's just doing the sum.
You need the total sum, so you need so that you can divide this value by the previous calculation.
By the total.
Yes.
By the sum total again of the whole thing.
This is the sum total, right? For each patient. So patient 56 got totally 99 votes across all the things, the seizure, blah, 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 whatever the LPD votes, GPD votes.
Okay. So you will divide each of the targets by the 99 for that patient.
So exactly.
To get the fraction.
Yep. So you get this.
Got it.
This was the first thing where we saw. Let's kind of do this again. Yeah, this itself took a while to kind of wrap my head around what was going on here. So now we have this 97 and 2. All you're doing is you're doing 97 by 9 and 2 by 9. Sorry, 2 by 99. Sorry.
99. Yeah, got it.
Yeah. Okay, so that's what this is what I think they're talking about is overlapping per se. Sorry, non-overlapping is what I think this means. Let's kind of go back. Where was it? All right. Okay. So if you look at, so these are the values. If you look at this is this 0.31 and this ends with like 0.27. If you kind of jump back here, yeah. So that's what you see with this patient ID. This 0.31 and 0.27. So this is non-overlapping based on patient ID.
So I think now I get it, because when you do per patient, you're kind of collapsing the fact that so in the data set for every EEG which has this overlapping, because in Steve's notebook that he pointed out, right, that there is this red and green or there's this overlapping readings, right? Like because you're getting a starting point and then you take a 50-second, but then another starting point can like start before the 50-second ends. So those are overlapping readings, if you will. But if
Okay.
you group by patient ID, then you kind of are just getting one reading per patient. So it kind of doesn't, you remove this multiple readings per patient, therefore overlapping. See, so that's what I got, because there are two concepts that are kind of overloaded in that. Because you're doing patient ID, you're getting non-overlapping. Am I right, Steve?
Yes, I think so.
Yeah,
Now I understand better, because I was very confused about this term,
overlapping
of the term non-overlapping. But now it makes sense. Like, because you group by patient ID, you're kind of eliminating the multiple readings per patient that you get because of the overlapping EEGs.
So wait, when you group by, how do you kind of get over? I mean, how are you?
Because you will only be, you're kind of averaging out the number, right? You're like saying, you're kind of summing it all. You're summing the votes instead of taking the vote per EEG, which could be overlapping EEGs, and then each overlapping EEG has a vote of its own.
Okay. Okay.
If you look at the data set, you see what I'm, each EEG line has a vote, right?
Right.
And that is, so some of the EEGs overlap.
Correct. Makes sense.
And so there is a vote per EEG, which are overlapping things. But when you do it per patient, it's like when you average over time, that means you're eliminating time, right? It's
I
like
see.
the same
Okay.
concept. When you're taking it per patient, you're kind of saying all of these votes that are there per EEG line, I'm kind of summing them. So you come up with one sum value, right?
Okay. Okay.
That's why he calls it non-overlapping. And this terminology confused me terribly.
Okay.
And now I kind of get a better understanding of this. Non-overlapping doesn't have to do with anything other than, like, because you're doing it on a per patient ID basis, your overlapping things don't have impact.
Right. Okay. So let's hold on
That's
to
at least
that.
my understanding. Is my
That's
understanding,
what.
by the way, let me test. Is my understanding correct, Steve? Do you think?
Yeah, so if you don't do any grouping, then things overlap because of the fact that, you can get the same reading from different EEGs, I think. So, so here, because of the fact you've separated it out, I think that's what it means.
Okay.
Yep, this cleared for me as well. This cleared it for me as well.
Let's hold on to that explanation and see if it kind of adds up with like non-overlapping based on EEG ID in this scenario. So this,
that confuses me again. But good point.
Should be it then. Like if you're, let's see if I have this. So this is what, okay, let me quickly look at what the scores were. So, okay, for non-overlapping based on EEG ID, it's like 152 and 42, right? Okay, yeah, so this is the one, this is the piece of code that.
Well, how is that happening?
So just rather than grouping on patient, you're grouping on EEG ID. So again, like each EEG ID, each EEG is for a specific patient. So again, you're grouping.
But I think there are multiple patients. I'm sorry, there are multiple EEG IDs for the same patient.
That's right, yeah.
Right, okay, okay. So in
this... Yeah, please go ahead.
No, so I'm saying, so in this, it's just that, so how does that non-overlapping terminology kind of come across here?
Oh, because again, sticking with what Steve said, because you are saying if there are 7 votes and there are 7 votes, 1 per overlapping EEG. So there are 7, let's say all EEGs are overlapping as an example. Some may not overlap, but forget that.
Right.
Let's say there are 4 overlapping and 3 non-overlapping, whatever. But there are 7 of them. And now by combining the 7, you have kind of eliminated and taking then the, the sum axis is more to convert it into a fraction. So forget that last sum axis equals 1 sum.
Right.
If you just focus on the grouping by the targets and the EGID, then you have grouped the things from the EGID. So you are now saying there are 7 numbers. That's it. It's overlap or non-overlap. It doesn't, you've kind of grouped it into just a total of 7.
Okay. Cool.
Yes.
Sorry, what is the terminology used there again? Actually, if you can go back to what
Non-overlapping is the one.
Non-overlapping, I think so. Yeah.
Yeah, so if you don't do any grouping at
Yeah.
all, your averages are across all of the EEGs, and like a single EEG may have multiple rows. So like there may, say for example, there might be an EEG which only has 1 row, and so like it would only have 1 set of votes, where like a second EEG may have 100 votes, and so if you just average across them, you'll be getting like things skewed where like the one with 100 votes will contribute far more than the one with only a single, even though like the one with 100, every single vote may be exactly the same. Whereas like when you group them together, that means it averages over the 2 EEGs equally. So yes, like that's the non-overlapping thing, in that you're considering each EEG as a separate case, and you're taking the average of all of its votes together and comparing that with the average of the other EEG.
Okay, so it's a non-overlapping specific to EEG ID. Yeah. Okay. I think I kind of get that
Okay,
one.
got it. I think
As I
that's an
get one,
excellent explanation, Steve.
yeah.
So just to repeat, so I get it into my thick skull, it's the fact that some EEGs, like you said, might have only, let's say, 2 EEG readings, but some might have 10. And by grouping it per, you're kind of making sure that the one which has 10 readings, all of which might be saying the same thing, but another one might have only 1, and you want the fractions to mean the same. So you, by grouping it per EEG, you're making sure that the 10 in the second case does not adversely influence, or does not, its influence is not much higher than the single row EED.
Exactly, yeah.
Why it's non-overlapping. Okay, got it.
Yes, so if you look at like an EEG which has a lot of rows in the training data, the votes for that are like normally quite similar. So like if you had like say 30 rows for a single EEG, you might find that all of the votes match pretty much the same. And so yeah, like as I say, like if there's like an EEG which only has a single row, its votes would be sort of not contribute very much.
Cool.
Got it. That's excellent explanation. Thanks. That helps clear out why the patient ID case was simple, but this one has a twist to it. So I appreciate your explaining that.
Raquel, you are using Jarvis Labs as your preferred compute? Okay.
So going on to the next one is based on spectrogram ID. Again, so now since we kind of understand what non-overlapping means, it's kind of just grouping on that, and you should be able to kind of see, that's all the changes there. So that brings us to this one. With overlapping, I was not able to produce these results. I don't know if anyone wants to take a stab or wants to kind
so can you just do what you did before but without any grouping?
So you're saying just pull off the grouping?
Yeah, so like for every single row, calculate its sum, and then like just divide the votes by the sum for each row. Yeah, so you don't have any grouping at all, I think.
Hang on, that doesn't look right. That
can be by patients, right?
So that's what you're saying, right?
I think so, yeah.
Right, but the total votes per patient can't be there, Raquel, because the division has to be by the total votes. not total votes per patient. You have the per pat
Right.
in the second row. In the second normalized votes, you have to divide by the total votes, not the total votes per pat.
Oh no, that's just a variable name.
Variable name, right?
Yeah, but do you calculate the total votes per patient, or when you're dividing, what are you dividing by? Is it by the total votes or on the second that way? Oh, yeah, first part that you can do now.
I think got fucked there itself. Wait, so it should be just divided by this, right?
I think so, yeah. Yep.
Wait, that does not look like.
What does your mean vote ratio line do?
Sorry, Steve, could you repeat that?
The line that you have commented out, the
Oh,
mean
sure.
vote.
My bad. Good catch.
Oh.
Wait, that.
Should it be 1?
Okay, so basically
maybe
we need to take. So these are basically the total number of votes for each of the.
yeah.
Right. And then we are saying we need to divide each of the rows by these for the respective columns? No, right?
Would you want to divide those by the sum of all of those?
Yeah, that's what I was thinking.
see.
You have to
Okay,
divide it by
okay.
the sum 93773 divided by the sum of what you get.
All this.
Yeah,
I
sum
see.
of that. Yeah.
Okay. Oh, sorry. So that should be just what divided by dot sum. But that also doesn't match, I think. Yeah, see that's a 0.19, 0.13. So something missing there.
I would expect this. That's what I would expect. But
so I have a suggestion. Shall I just share this?
yeah, go ahead.
No, I was just going to say, shall I share this notebook? We all can kind of go through this.
Yeah,
There's some more
no, that'd be
interesting.
good.
Yeah, there's some more interesting
Yes,
stuff
please.
down there, and then maybe next time we can start our conversation with this.
Yeah, no, in fact, I had the this was one of my first questions too, is what does he mean by this overlap and non-overlap?
Yeah,
How does he calculate?
there is some chat down here where they talk about, yeah, there is some overlap stuff. Yeah.
But that
it'll be good
explain.
Right. It'll be good if all of us kind of go through that and then we have this discussion.
Absolutely. No, please do post it on Slack and we'll take a crack at it, because I think I wanted to do this myself. So great.
We have like 5-10 minutes. Can I quickly run through a couple of other notebooks and then maybe we can look at them and then have a discussion next time? Does that sound good?
Sure.
Okay.
Yeah.
So that was the EDA one.
One quick question while you pull it up. I had one quick question. To maybe Steve can comment on it. Is so is it always the case, Steve, that I think it seems to be the case, but it's nowhere recorded. It just seems to be a default of how the way the data is, that all the spectrograms have this 2 seconds per row, and that seems to be somehow standard. Is that how you understand things as well?
Well,
that every row represents 2 seconds.
Yeah, these spectrograms are like that. Yeah, every single spectrogram in this competition is 2 seconds apart. Whereas
every spectrogram provided, but some spectrograms that are provided are much longer than the 10-minute, or is everything a 10-minute spectrogram?
No, the spectrograms can be longer, as I say, like in the training data, there's like an offset giving you the time into the spectrogram. So yes, like one single spectrogram may be used by multiple EEGs. So like that's why the spectrogram time can be longer. Although, as we said, like when you get the test data, the test data, each spectrogram will only be 10 minutes long.
Yeah, okay, got it. So because of the fact that the start time from the beginning of the spectrogram could be like some 8 or 10 or whatever, and then from there, from that time point, you would still have a 600-second window, right?
Yeah.
So that's
Yeah,
why
so it's the
spectrograms
same.
can be much longer.
Yeah,
Okay,
so it's the
the
same
other
as
thing
like
I just
showing there, like that's like an EEG. So like in this case here, like this EEG has multiple windows, and again, like there's like in the training data, like there's an offset to where the 50-second window starts. So it's the same with the spectrograms. The spectrogram can be used by multiple rows.
right. Okay, and the other things, Ricky, because you had pointed this out previously, and I somewhere in Chris Diot's discussions and stuff, he highlights that is it's not always the case that the offsets of the EEGs and the offsets of the spectrogram coincide, which happens to be the case at the beginning, but that's not always the case. There are exceptions.
I see. And I think there's another problem with the offset is, at least when I was looking at the data, since these spectrograms are every 2 seconds. So for example, if you want to go like halfway in between, then you can't do that, right? Because it has to be like a multiple of 2.
Yeah, so if you look at like anything that's taken windows out of the spectrogram, it divides by 2. Yeah.
I see. Okay. Okay.
Because of the 2
You divide by
seconds.
2 and then again by 2.
Yeah, like that's to get the middle point. So if you've got like a minimum and a maximum, you divide by 2 to get the minimum point. And then because every row's 2 seconds, you divide by 2 again. So you see quite often in the code people dividing by 4.
I see.
Yeah.
Okay.
Right.
So
and
that
that's why.
is
Yep.
so in the spectrogram, the 2 is actually not 2 seconds. Is that 1 second? It's like 2 half seconds. Is that what the 2 mean? Or is this something that we are doing just for convenience?
So in the training CSV file, it'll tell you the offset into the spectrogram in seconds. So for example, it'll say, yeah, like this window starts at 6 seconds in the spectrogram, but each row within the spectrogram is every 2 seconds.
Okay. Okay.
So you would want to take, if it was like a 6-second offset, you would want to jump 3 rows. So you'd want to jump 6 divided by 2 and go to the third row of the spectrogram data.
I see. Okay. 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 That kind of makes sense. Okay. Cool. But yeah, this is Steve's notebook itself. Like, I feel like this was kind of the most eye-opening figure for me, which kind of made sense. So many things, so many questions.
That is and to me, that's what overlapping meant. So then, when he starts using overlapping in this grouping thing, then it confuses the hell out of me. I wish he had used a different term, grouping or something, right? Because I kind of, in my mind, I kind of confused the two, the overlap that Steve has shown of the time windows, and then the overlapping, when the guy refers to overlapping, he refers to it by the grouping thing, which we have discussed, right? Whereas the overlapping is actually an overlap of windows, as Steve pointed out. So
yeah, Benito, or I don't know if anyone else who's kind of still trying to handle how to grasp the data. I think like Steve's notebook, like this one is an excellent one to start with. I think Steve does like a great job, like even corresponding how the data maps up with these numbers. So yeah, it kind of really helps understand stuff. The other one that, sorry, this is the other one I wanted to kind of look at was, this is the WaveNet one where he's using the raw EEG features. And like I said, I think you can use all of them, but in this notebook, he's just using this FP1, O1, FP2, and O2. And yeah, so what was the specific thing I wanted to point out was Here only, right. So this is what we were talking about, like kind of grabbing the center. So you have this whole, extract the middle 50 seconds. Um, this kind of is the way he kind of pulls out those middle 50 seconds. And then I think after that, everything is kind of, pretty straightforward, like in terms of understanding how the data is being processed. Um, and where is
Middle
the
50 seconds of a spectrogram.
the EEG rather.
Oh, sorry, of the EEG. Oh.
Again, like we were talking, we
middle
have those
50.
offsets, so you can keep moving ahead, but he's just extracting those middle 50 seconds. Again, I'll share this notebook.
Wait, hang on. So I haven't gone through. Okay,
Yeah, that's right.
rather than figure out, I'll just go through it offline.
Yeah, I'll just kind of put these out there, so maybe next time we can discuss when all of us kind of get a chance to look at it. Because of all the noise, he kind of uses the low pass filter to kind of clean things out. And then just build a simple wavenet and then you pass through that stuff. So in essence, I think Benito was talking about like these being the two kind of ideas where at the end of the day where you can actually combine all these together. So that's why I was saying like there are at least two of these ideas which can be combined further. You can get whatever.
By the way, since we are on this, like if you go back, just go back a little up. So interestingly, there is a good discussion, and I thought, at least this is again, good tips to jot down from these experts. So, like, for example, he uses group K-folds, and he groups on patients. So, the patient that you train on don't show up in the validation and vice versa, right? Like basically you don't have validation patients show up. So he just groups, and on the other hand, the image guy does stratified group, and he stratifies it on the classes as well, because you want to make sure that the class distribution, even after you're grouped by the patients, is still maintained across the folds. And actually there is, exactly. So that I think this tip is also kind of a useful thing to keep in mind, like what Chris says are the reasons that he uses group versus versus stratified. So one of the simple things I wanted to try was use the notebook that the guy which he uses with the images, but he does stratified. And because Chris claims, hey, it could generalize better, is to see whether if we use group without the stratification, whether the score is the same, less, or more.
Yeah, good point. Yeah, something worth trying there. Cool. That is the other one. What else? This is the baseline. This is a really nice and simple notebook. What is it called? If someone can pull this up in the meantime and just share the.
Yeah, that's a notebook that's currently leading the public.
Yeah,
and the training notebook of that is public as well.
Yeah. Oh, shoot. I shared the inference one. Okay, sorry, my bad. Yeah, this is the one, the training 5-fold one.
That there's not actually there's another one. You can see like at the top it says 224 by 224.
Okay, 512 by 512 is the one that should be.
Yeah.
Well, I think weird. Okay. Good point.
There's definitely one there called 512 called 512.
Oh, I think his inference is called 512.
Yeah, it's there. In fact, it's there on the baseline, right in this cell. You see the top one, right in the cell that you're showing, the top line.
Yeah, these two are the ones,
comment, right? There, those are the two. Yeah.
So those are the notebooks.
Right. The one thing, sorry, since we are on that notebook, I just had, if people are looking at it and certain things that I jotted down as questions that maybe we can discuss next week and stuff. But one of the things he does, and I am not, honestly, I'm not very familiar with the whole typing kind of stuff in Python. So he uses that in the notebook later down the later on down. And I was just curious whether somebody who's familiar with how typing works can quickly explain, since there are examples of what he's
Where
trying to do. I mean, I kind of intuitively get it, but I prefer a clear
that in this
explanation.
notebook, Srinivas?
Yeah, in the training notebook, not in the inference one. So
Right.
I don't know whether it is the 224 one, but it's definitely there in the 512 by 512 one.
Okay.
That he kind of goes through and does, typing related Python typing stuff to handle
Right.
tensors, tuple of tensors, dictionary of tensors, things like
I
that.
saw-
I understand what he's doing, but I would just like to know what's the
I-
purpose and how does typing
I
work
don't
in
think
that
that is
instance.
this notebook, Srinivas. I
No, I
think
think it's the other
that
one.
It
I
is
think
there
it's,
in the 512 by 512.
no,
It's there in the, let me
I think
show
that's the
you.
efficient net
I
one.
think it's in the one that was leading the public. If you go to like the public code or whatever, I think it's the second one.
Yeah, I have it here in the chat.
Yeah, that
Yeah, so
the HMSH back one, the fourth one.
This one?
that's again inference, right? I'm talking about, I can
When you say
share the
typing,
notebook that I had pulled up if you want.
do you just mean like typing as in giving
Yes.
types to
Yeah,
the
right there,
variables?
right there, right.
This
Like
is
this
what-
is simple, right? So he's just saying I'm going to create a union of blah 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 strings as a path and a label which could be int, float, or whatever. So that's fairly simple, but then he does a little more complicated stuff
But
similar
the
to that
typing
I
is
just wanted
sort
to.
of, I'm not sure if you're familiar with like JavaScript and TypeScript. It's just the same as that, isn't it? It's like basically you're just sort of making your code a bit stricter and like saying what type you're using in functions. So
Yeah, and that's where
all
it
it is,
was. That's
it doesn't actually affect the performance of the notebook. It's just like to help
It-
you understand how the notebook's operating by telling you
okay.
what type things
Yeah,
are.
there were some specific questions. We can discuss that later. And I'll make it more specific. The second thing was I just wanted to mention the points that I had a jotted down question on. Second was this what he does with the KL div. Loss, he converts it to legits, and then KL div loss legits for validation as well. And that was something I kind of wanted to. Regularly, if I may, I can share the exact notebook that, because this one, while it's similar, it still isn't exactly the same.
Yeah, this one.
So let me just share the notebook that I'm talking about, and I'll post a link to it in Slack as well. And that's the one that I used. In fact, I ran it last night. Can you guys see my screen?
Yep.
Okay, so you see this. That's the ResNet 34, the baseline training. And so this one is the one that at least I used and created, and I ran the corresponding inference notebook and got the same results that he did. This is the one that I'm referring to. This is the one which has the 512 by 512 training. Is here, and it's not the 224, 224. It converts it to a single 512 by 512 at size 32. And then you obviously normalize the image and all that. The couple of questions I had was, if you go down, because that, again, I haven't compared, the notebook you shared, Raquel, or the 224 by 224 one, but wanted to also understand the
Yeah, I think it's right down there in the training section is where I think you're looking for the typing stuff.
yeah, these two, right? Like, specifically getting the mean I understand this part is easy, but then what he does for validation, to be honest, I haven't gone through it, but just, I had a note that to understand why or what he does with this. It may be simple, but I
I
still,
haven't seen that.
explain it to somebody, I could.
Yeah, how about
So
you
that's
post the
one.
notebook and then kind of how
Yeah.
about we post this notebook and then have a thread under each of them and have our questions there. Maybe then we can kind of go through it next time, because I think like so many of us are looking at so many different notebooks. It's kind of hard to catch something on the fly. Does that sound reasonable to everyone?
Yeah,
Yeah.
it
Okay.
does.
And then also how he splits the spectrogram file. There's some splitting going on. Not the fold. So the see here he uses stratified group fold,
Right.
what I talked about.
Right.
Right? Splits it on expert consensus, whereas the groups are of patient ID. So one simple thought is, if you could convert this to group K-fold and then see whether it produces better or worse results.
Right. I think all these CNN notebooks, the other interesting thing was since you're pulling in spectrograms and the range of those values are so varying, how I think Chris mentioned somewhere in the discussion how they're doing like a log of it and then like clipping it between two values to kind of switch the range
-4 to
down.
+8 or whatever, and that's the range of your values, and then you click, right? That's the one you're referring.
Exactly. Yeah.
Yeah.
So that pre-processing step is kind of,
Correct. One question I had for Steve was, he kind of, in this case, for example, he's using the 600 seconds of the first offset and only the first offset spectrogram, correct?
Yeah, I'd noticed that about this notebook. Yeah, like I was intending to, so he only uses the first window from each spectrogram. So
right.
Yeah, like I was like going to try and get it to like use all of the windows for the spectrogram. So he's at the minute he's only training on one window.
Right, but how would you do that? Meaning you would concatenate it and stretch out the spectrogram to like.
No, like if you look at his code, he'll take the first offset that's in the training set for a spectrogram, and then use the 10-minute window for that spectrogram. But yeah, for the same spectrogram may have like multiple other windows, and he's not using them in the training. So yeah, so I was just going to expand it so as it uses each of the windows.
So, but what I'm saying is the windows would also, these windows would also overlap, right? So would you just take variable size windows, or how would you collapse? Like, let's use a simple example. Suppose your offset is 2, 4, and 6 seconds. So then from 2 seconds, you would have to 600 second addition. So it will go to 602. If it's 4, then add 600, it will go to 604. From 6, you add 600, it will go to 606. So were you planning on using from 0 to 606? But if you do that, then the size of your spectrogram window will vary on each case. So you would have to standardize that, right? So how are you thinking of doing that is what I'm asking.
Well, at the minute, so like at the minute, he'll take the spectrogram from 2 to 602 and use that. But he wouldn't use from 4 to 604, and he wouldn't use 6 to 606. So he would only have like one row for that spectrogram in his whole training set. So yeah, I would just keep the 10-minute window, but yeah, just like start at different offsets. So for like this spectrogram, I would have 3
channels, or how would you use them?
No, I would have like 3 different rows in my training set. Rather than having one row, I would have 3 rows. So that spectrogram would have 3 rows in the training set as opposed to just having a single one.
Oh, so you would have 3 spectrograms is what you're saying, and therefore your training set would increase to not just be the 17, not just the, but at most it could just be the 11,138 spectrogram IDs, whereas he would currently have a lot less than that. Am I right?
No, at the minute he has the 11,000, but mine would increase for each window in the spectrogram.
Oh, I see. Okay. I see what you're saying.
So that is like some form
So it
of
would be
data
more than the
augmentation.
11,138 because you would have all of those different windows which are embedded within a single spectrogram.
Yeah, exactly. Yeah. Yeah, because like Chris Diot does it differently. He doesn't just take the first window. He takes, as I said before, he averages over all of the windows, and like then he considers like 10-minute windows from the start offset until the last offset. But in his case, you might have problems because of the fact that within some of the spectrograms, you could have like a first window, and then you could have like a big gap where there's no spectrogram data, and then you might have several other windows. And like in Chris Diot's case, he would take the minimum start time and the end start time, and then he takes 10-minute windows randomly anywhere between those 2 points. So in
He does that.
certain cases, he could end up with like invalid data.
Right,
So,
or no data at all. Whereas this approach of that you're thinking of, which is don't just take the first window, but take every window present and add those as rows, and then use all of those spectrograms. So your spectrogram training data increases.
Yeah, exactly.
Will help. Okay, got it. And because he is going off of the label ID, I think you won't have to change much of the notebook because the label IDs are all different for each of the windows, if I recall correctly, correct?
That's right, yeah.
That was one other thing I had made a note of, that he's using only the first spectrogram, and is there an opportunity to do better than that? Yeah, too. Oh, sorry, Beto, interrupted you while you were in the flow, so I can stop sharing.
No. Let's quickly finish. Yeah, this is the WaveNet one. I think I already shared that. What else is there that I wanted to share that I found interesting? Oh, this is an interesting post about KL divergence, the limitations, and when to use it, when not to use it, sort of a thing. I thought it was a good read.
I didn't think that.
How to make spectrograms from EEGs, we discussed that. I think you have shared the notebook. I mean, the discussion post. This is
is that Chris or is that somebody else?
Yeah, this is Chris. This is the notebook as such, and I think the discussion post was already there. Yeah, this was.
Okay. Yeah.
This is the one. Whoops. Okay.
I love the term double banana montage.
What else was there? Yeah, this is the same ResNet stuff we spoke about. What is this? This is just an overview. Okay, never mind. EDA.
One thing efficient that I completely got lost on, totally lost, with no clue, is what he does in the EfficientNet notebook that Chris has posted, and then he says a comment of crop to 256 time steps, and then he just does this weird clipping. So if there's anything there that's maybe Steve understands, or you grasp.
Yeah, he clips that he clips it so as he doesn't have to like resize the image for the ImageNet, rather than because he wants to use like pre-trained EfficientNet. he uses like the ImageNet weights, and so he wants to keep
Yeah,
the,
right there, right there.
input
Hold
size
up,
the
hold up
same. So,
for a
so he
minute
clips it.
there. Yeah, see this 14 to minus 14 and then 22 to minus 22. I was like, what the heck is he doing there?
Yeah, so as we've said, like each one of them's 2, so you need to.
I see. Yeah, I haven't seen this part yet. Okay.
Right, and it was just like everything else made sense until he's averaging the image, he's clipping it, he's taking the log, blah blah blah, in the range of 4 because he's making 4 channels, and then he does this 14 minus 1. I was just like, oh my god, figure out what the heck is going on.
Yeah, so if you were to look at the shape of that, you'll see that it's the shape of the ImageNet input.
I see. Okay.
He needs it to be 224 by 224, so he's just chopping it to be that size and doing it in the middle kind of thing.
Yeah, something like that. Yeah. So.
Okay. I think it's because EfficientNet is really finicky about sizes, right? Like whatever it's been trained on, you really need to kind of pass it that size to get your best accuracy. At least that's
I
what
think so. Yeah. So in the comments, yeah, like within the comments of this notebook, somebody asks him about it, and he's like he explains like why he's done it.
I see. Okay. Cool. Good. Look at that one. Sorry, I can't find it. Ah. Model requires a dimension divisible by 32, and I don't want to use resize.
Yep.
Okay, but that is that. Okay.
Yeah, and also I was not familiar until I saw this notebook.
Okay.
Maybe Stevens used it, but this nan mean and nan standard, I didn't know that you could do that. So that was something I learned. I assume that means ignore nans and take the STD and the mean.
Yeah.
So,
otherwise, mean will take it.
Yeah, so like he uses them a lot in his cat booth.
Kind of thing is interesting. I didn't know that those options, maybe they're new or maybe they were always there and I just have never used it.
Yeah, I've also never used it.
Sorry, NumPy.
To drop the nans and then kind of do that calculation, but that's really a nice.
Yeah, nan mean, nan STD, and even the nan to num. In the image NP nan to num, I've never seen those 3 stuff. So, and he defines nan to be 0.0. So that was like interesting too, that you could redefine nan on the fly to say, okay, if it's 0, then, or
that's kind of like fill NA, right?
Zeros. Yeah, fill NA, but it seems that but the fill is an automatic 0 or something, or you
can pick the value. You can pick a value.
Okay. Okay. So this is similar. Okay, yeah.
So I think is this what Steve you were pointing at?
Yeah, I think so. Yes.
Okay. So I guess something here. We can look at this next time too.
Okay, good. Yeah, obviously.
Oh, sorry. Yeah, I kind of have. That's also. Yeah, I was just thinking. What do you think? Like next time, should we kind of go through the notebooks we have, discuss, put down here, create threads under each of them questions. So beforehand, maybe we can answer some of them. So
that'd be good. We still haven't figured out that something of how the non-overlap or overlap thing happens, right? Yeah, that itself was in fact my first question. So I'm glad I'm not the only guy. I was like dumb enough not to know what the heck is. But it's a puzzling thing.
I put that out.
Yeah, it takes other people to point out. So good. So we look at that. Yep, that'd be good.
Yep.
But definitely an interesting competition. Especially, I'm curious as to how people combine EVs and spectrograms and of course ensembling, but
I'm thinking of models being used where you use the last features from each of them and trying to kind of throw in something.
more of a true multimodal kind of a thing.
Right. Yeah, exactly. Yeah. Yeah. Oh, quick question. So all Steve's notebook, I mean, sorry. Damn, sorry, Steve. Steve and Chris and is there anyone who's seen a notebook which uses multi-GPU but not TensorFlow? Chris's notebooks.
Yeah. I saw your question. There are some, not in this competition. I'll post links to them.
Okay, awesome. Yeah.
There are some, but all of them have their own quirks. Steve, I thought you had one in PyTorch that used multi, or am I misremembering?
Yeah,
and that
no,
was also
I have, but yeah, it is harder to get it to work in PyTorch than in Keras.
Oh, really? Oh, okay.
But yeah, you need to like fiddle about a bit. But yeah, there are notebooks out there with it in.
Okay.
I thought Accelerate library from Hugging Face helped. Is that?
It does help. I can do everything outside Kaggle, but when it comes to Kaggle and it runs on Kaggle, but when I submit it fails and gives me that ominous error that has no explanation because nothing comes back when you submit, right? I have the accelerate.py stuff, which actually runs on Jarvis, runs even on Kaggle before I make a submission. So yeah, that's why I'm very desperate to kind of see if someone has something that I can work off.
Oh, that I don't know whether the submission part will work, because anyway, let me point you to a few later today.
And by the way, was everyone aware when you make a Kaggle submission, there are two runs that happen, right? And the first run that happens is running your notebook, which actually counts towards your GPU.
Yeah, so like in other competitions, I've added stuff in where it doesn't do because of the fact when you like save it, if you're not that interested in the notebook output, I've set things up in the past where it will just like sort of make a dummy submission file rather than processing the whole thing.
Yeah.
And because you can tell, so like in this case here, there's only like a single row in the test.csv file. So for example, you could look and see how many rows, and so you know like when you're saving and when you're submitting. And so yeah, like I've used techniques like that before, so as it doesn't do a full save, so as it doesn't eat all your GPU. And like then, as you say, like when it's actually sort of doing the submission scoring, then it's not using your quota.
Yeah, last week I was like making all these submissions, and then I suddenly see like in a couple of hours, like run out of 5-6 hours of GPU. I'm like, what is going on? I'm like, I've turned off everything, and then I realized that, oh, okay, fine, that's where. And yeah, I remember that. So that is why people were using that if condition and checking your test.csv stuff, right? Like if your number of rows is less than.
Yeah, exactly.
Yeah. And then I kind of started digging around a little more. Where can't see. Let's see if I can find that. There.
Sorry, I didn't quite get what the workaround, Steve, that you were talking about. Or I mean, if you submit, then it runs reruns the notebook.
Exactly. Right. And that counts towards GPU hours.
Right. And what were you saying? The way to avoid that or sidestep it or something? Like I didn't grasp that.
Well, in this competition, it's not so bad because there's only a single file in the testing. When you save your notebook, it'll run the notebook and it'll eat into your GPU time. So what you can do is you can look at, like, for example, in this case, you could like look to see how many rows are in the test.csv. So if there's only a single row in the test.csv, you know that you're saving the notebook. Whereas like when you pick your submission file and click submit, in that case, then it'll have the full test.csv file. It'll be more than a single row. So like in that case, then you can say, okay, I want to run all my code now. And like when you're doing the submit, it doesn't use your GPU up.
Does that make sense?
Oh, when you hit the submit button, it's not using your GPU, your hours, you're saying?
That's right, yeah. It's only using your
as
GPU when you
opposed to
save a notebook.
but when you save, can't you just save without, like, the first option save, where you just save the notebook without generating the output? Isn't that
No,
the simple?
no, because in that case, you need the notebook when you save it to generate a submission.csv file, so
Yeah.
as you can
Right.
submit that to the competition. If you do the fast save, it doesn't generate a submission file, and so
Okay.
you don't have anything to submit to the competition. So you need to pick regular save, but when you pick regular save, it'll try to run your complete notebook. And so if your notebook's doing like a lot of stuff, it'll eat all your GPU time up, which is why, yeah, like you can sort of see that. So it's like trying to do a fast save, but at the same time, generate the submission.csv file so as you can submit it to the competition.
So then, and in that case, you say you have some flag to execute it, but with minimal rows.
That's right, yeah.
Basically, you look at your test.csv, and if you know that your test.csv has only 5 rows, but whereas when you make an actual submission and you're going to be scored for the leaderboard, it has to be more than 5 rows. So you can kind of create something like this, where you basically check what the length of your test.csv. If it's less than 5, you basically jump out. So that'll finish the execution of this notebook. So you won't be eating any more of your GPU hours, and you can throw this pretty much right at the top after your imports, or actually write out the submission.csv over here. So you
Yes, like there you would just write out a dummy submission.csv.
to your, and this else is where you would have actually done what your code is like. I don't know, your cat boost and your LGPM and all that stuff that you want to train sits over here. And this run, when it actually happens, will not eat into your GPU hours. The shitty thing about this is, if you have an error, even while submission, like if there is a simple error, it'll not get caught because it jumps out of your notebook right over here. So you won't be able to see this. So this probably, I don't know, at least from my understanding right now, is something you need to use later on in the competition, when you kind of have everything set up and you know your notebook's going to run like for 6 hours, 7 hours, but you're making like simple tweaks of maybe changing weights on, yeah, some ensembling stuff and etc. like that. So I kind of little bit deep dived into that, and when you submit, it opens. So I always submit like this. I hit the submit button here, and then I just fill this up. I don't know. Looks like you guys do it slightly differently. So when you hit submit,
well, you generate the output, and then you can hit. You generate the output, and then you can just go to your notebook and select your output. Like it has the input, output, and all that, right?
I
So you
see.
select the
Okay.
output,
Okay.
and then there is a submit button that shows up there.
Interesting.
So
Okay.
that's the way I've often done it, but I have occasionally done it this way too. But if you go
Okay.
back to, like, if you just go to the top of this notebook, for example, and you do the not here, but after you run it, I think you can.
Yeah, no, the output's not there because of the fact you're editing this one. You need to be
I
in
see.
one.
Right. If you have
you're
to get
editing
out of
saved.
edit mode.
Cool. Actually, I don't know. So maybe in that case, I don't know if you eat into your GPUs. Is that true, Steve? Like, do you still eat into your GPUs when you submit from that stage?
No, it never uses your GPU to submit. It only ever uses your GPU to save.
Oh, I see. Okay. So in that case, you have to, okay, I see. So in this case, when you hit submit, it basically opens up what is running here, and you see there are 2 notebooks that actually, let's just do this. I'm going to do this now. This is so much easier. So you see there is one, yeah. So there you go. 2 active notebooks are running. And this is the one which is for the competition submission. This is the one which is going to run my notebook now. So if there are any errors, like for example, I think I added that if test stuff. So it's going to break here. And you'll be able to see, yes, it says failed, and you can see it. The other, so now I can actually click this, and you should be able to exactly see what the problem was.
Yeah,
so it's nice. But there is another way you can do this, and that is when it's running, if you don't want it to run, click this, and then there is an option which says cancel session. You can hit cancel session, it'll stop eating into your GPU hours and it'll directly go into the scoring. So you save that time. But what I realized is since you kill this, if you open this, it doesn't open a notebook, it'll open the script file, because that's the script file that is running during the final submission. So then if you try to look, it doesn't look anymore like a notebook. It'll look like a JSON, which is really shitty. It's like the Jupyter notebook as a JSON dump. But if at all, yeah, sometimes I remember that, okay, it's running for too long and I just want to kill it. I don't want to eat my GPU hours. Then there is an option to do it that way. And then
yeah, I think Kaggle UI leaves quite a bit to be desired. And the other thing which frustrates me is they sometimes keep changing stuff on you, and that is like, oh wow, it used to be here. Where the hell did it go? So,
but looking at it, Kaggle apparently introduced something new, which is this. Let me share that. So this flag that you have, Kaggle is competition return, is something that can be used. Sorry, is competition rerun. And yeah, this is the other so-called cleaner way of doing it that I saw in someone else's code. So at
All
least
right, so you don't need to check the test file to see how many rows are in it
yeah,
or whatever.
exactly. Yeah,
Okay.
so you can kind of do it this way. It's still kind of weird in the sense that your notebook will still exist, like it's not the shitty way which I was saying where you can just cancel the thing where it'll become a script. You'll just see an error after this because it would have just, you're doing sys.exist, so it'll just say, don't use this, use Control D to exit or some shit like that. But at least your notebook is still there in peace. Yep. Those were kind of the three ways that I had seen. So hope that's helpful.
yeah, no, I haven't seen this particular way.
Yeah.
Good deal. Any other questions, Benito or Mayank, or is anybody else online? Yuri?
Not for me. I have to go through the notebooks here a little bit because I'm still at the beginning of the analysis of these training models.
Yeah, me too. I have to go through the spectrograms and the ECG part and make sure I get the exact overlapping versus non-overlapping ways of how to do that stuff.
Yeah, nothing from me.
Oh, a lot of stuff to dive into. The good thing is, I think we are, jumped into the competition right at the very beginning. So it's kind of good feeling because we are not like terribly behind or whatever.
Did you see that the first update of the Optiver competition's out?
Oh, really?
Oh, really?
How's it
The
faring?
first,
How are you faring there, Steve?
I'm 33rd or 38th or something.
Sweet.
So
Okay.
yeah, so like they've
Most
evaluated
frustrating
the
competition
first
that
one. Yeah.
Damn, that is nice. Cool. So I think just a suggestion, if you guys look at any of the notebooks that are there on Slack, if you have questions, just open a thread underneath that and then start dumping your questions there. And hopefully one of us can answer beforehand or during the call.
Yeah, no, that'd be great.
Fine with
So we
everyone.
can keep it as we dive through it, and if we find out something like even this minus 14, whatever slides, it's good to know that there's a comment and kind of
Right.
it and get it out and then post it. Even if it's there, if it's not as clear or you have stuff to add, that makes it
Correct.
easier to grasp. Those are all the good things to comment. So let's keep the, don't answer yourself on whether something is or not. Another way of looking at what somebody has said might still be great. I think it's a good, excellent discussion, and we will more of it and more approaches will come to the fore as time goes on to the competition and a good time.
All right, guys, take care.
Thanks, Steve, for
Okay.
posting your notebook. That was very helpful as Raquel has pointed
Oh my God, yeah. That diagram If I close my eyes also, I can see that, Stephen.
Mhm.
Was too
Glad you
good.
liked it.
Yep.
Okay, cool. See you next week.
All right, guys.
Thank
Yeah,
you.
see you next week.
Bye bye.
See you later.
Bye
Bye.
bye. Take care.